Hello friends, in this video we see the topic GCD and LCM. GCD means greatest common divisor. It is also called as HCF, highest common factor, and LCM means the least common multiple. Okay. Recall that the set of integers is denoted by Z and it contains numbers 0, 1, 2, 3, 4, 5 and so on, -1, -2, -3, -4 and so on. Let's see the definition of divisibility. Let a and b are two integers with a non-zero, then the integer a divides the integer b if there exists an integer q such that b is equal to a into q. Means if you can write b is equal to aq for some integer q, then we have to say a divides b. It is denoted by a vertical line b. For example, 2 divides 6 because we have integer 3 such that 6 is equal to 2 into 3. Let's see the definition of GCD, means HCF. Let a and b are two integers with a is non-zero or b is non-zero. Note that a and b both cannot be 0. At least one of them is non-zero. Both a and b can be non-zero, no problem. Then the positive integer d is said to be greatest common divisor of integers a and b if d satisfies following two conditions. First condition is d divides a and d divides b, means d divides both a and b. It means d is a common multiple of a and b. Second condition, whenever k divides a and k divides b, means whenever k is a common multiple of a and b, k is less equal d, means d is greater equal k. Means first condition says that d is a common divisor of a and b, and second condition says that d is greatest among all the common divisors of a and b. It is denoted by GCD of a and b. See, for example, 4 is the GCD of 8 and 12 because -1, 1, -2, 2, -4, 4 are common divisors of 8 and 12, and 4 is the greatest among all these common divisors of 8 and 12. Means 4 satisfies both these conditions for integers 8 and 12. So 4 is the GCD of 8 and 12. Okay. Note that if a divides b, then GCD of a and b is mod of a. And for any two integers a and b with a is non-zero or b is non-zero, you can see that GCD of a and b is same as GCD of a and minus b. It is same as GCD of minus a and b, and it is same as GCD of minus a and minus b. And if GCD of a and b is 1 with a non-zero and b is non-zero, then the integers a and b are said to be relatively prime or co-primes. For example, GCD of 4 and 9 is 1. So 4 and 9 are relatively prime or co-primes. That's the definition of LCM. Let a and b are two integers with a is non-zero and b is non-zero. Note that here both a and b are non-zero. Then the positive integer m is said to be least common multiple of integers a and b if m satisfies following two conditions. First condition says that a divides m and b divides m, means m is a common multiple of both a and b. And second condition says that a divides k and b divides k for positive integers k, means k is a positive integer with k is a common multiple of both a and b, then m is less equal k. Means first condition says that m is a common multiple of a and b, and second condition says that m is least among all the common multiples of a and b. It is denoted by LCM of a and b. For example, 24 is LCM of 8 and 12. Since 24, 48, 72, 96, 120 and so on are positive common multiples of 8 and 12, and 24 is smallest, least among all these common multiples of 8 and 12. So 24 is LCM of 8 and 12. Note that if a divides b, then LCM of a and b is modulus of b. And for any two positive integers a and b with a and b non-zero, then LCM of a and b is same as LCM of a and minus b. It is same as LCM of minus a and b. It is same as LCM of minus a and minus b. And note that if GCD of a and b is 1 with a and b are non-zero integers, then LCM of a and b is modulus of a and b. If a and b are positive, then LCM of a and b is nothing but product of a and b. Let's see the relation between GCD and LCM. For positive integers a and b, GCD of a and b and LCM of a and b is same as product of integers a and b. Product of given integers a and b. Okay, let's see the proof. Let d is equal to GCD of a and b. Then we can write a as d into r and b as d into s for some integers r and s with GCD of this r and s is 1. Since d is a greatest common divisor of a and b. Let m is equal to a into b by d. Then we can write this m as a into s. If you replace this b by d into s, then d cancels and remains as, means m is as. Similarly, by replacing this a by dr, d cancels and remains r into b, means m is equal to b into r. It follows that m is a common multiple of given integers a and b. And we claim that m is a least common multiple of a and b, means m is a LCM of integers a and b. Let k be a positive integer with k is a common multiple of given integers a and b, means a divides k and b divides k. We claim that m is less equal k, means m cannot be greater than k, means m is a least common multiple of a and b. Okay. Since d is the GCD of a and b, we can write d as a into x plus b into y for some integers x and y. So we can write k by m is equal to kd by ab. Since we have m is ab by d, so k by m is kd by ab. Replace d by ax plus by. Then by separating denominator, we get kax by ab plus kby by ab. Now we can see that from the first term aa cancels and remains kv into x, and from the second term bb cancels and remains ka into y. Note that b divides k, therefore k by b is integer, so k into b, k by b into x is integer. Similarly, a divides k, so k by a is integer, so k by a into y is integer, and addition of these two integers is again integer, means k by m is integer. Since k by m is integer, we can easily observe that m must divide k. And since both m and k are positive integers, m must be less equal k. It implies m is LCM of a and b. But m is ab by d, means LCM of a and b is equal to ab by d, means ab by GCD of a and b. So we can write it as GCD of a and b into LCM of a and b is equal to a into b, means product of GCD of a and b and LCM of a and b is same as product of given positive integers a and b. Thank you. Please subscribe this channel for more such videos. Thank you.